So I'm Masashi Sugiyama from RIKEN and the University of Tokyo. So I'm interested in machine learning, in particular theory and algorithms of machine learning. So nowadays, AI is quite popular in many applied side, but I try to focus on the fundamental side and try to develop kind of basic technologies of machine learning. And in 2006, I was with University of Edinburgh as a Erasmus Mundus Fellow, and I stayed here for 3 months in total. So that was a really nice experience, and I started working on reinforcement learning in this university. Since then, I was really working on reinforcement learning and also a lot of new machine learning topics. And now, I'm still continuing doing the same thing. So when I came to University of Edinburgh, I was already an associate professor in Japan. So I was a kind of visiting associate professor here, and I co-supervised 2 master students of informatics school. And these students are really good, and we did a great project on reinforcement learning. Yeah, RIKEN is a national research center in Japan. It has a long history, so more than 100 years in Japan. And RIKEN is quite known for physics research, chemistry research, medical research. But nowadays, they are also doing informatics research. So we have Supercomputer Center and our AI Research Center. So in 2016, we started a project called Advanced Intelligence Project. So and we are actually one of the 3 national flagship AI projects done in RIKEN, and I'm directing that center. So at RIKEN's AIP, so Advanced Intelligence Project, it's called AIP. So we have 5 missions in the center. The first mission is to develop fundamental machine learning technologies. So we hire a lot of mathematics people, like theoretical physics people, and machine learning people to really explore fundamental topics of machine learning. Then the second challenge is to apply AI to accelerate scientific research. Like in material science, medical science, they need the help of machine learning. So we try to support their project by AI. Then the third challenge is to contribute to the societal problems in Japan, like elderly healthcare or natural disasters and education, things like that. Then the fourth challenge is to work on ethical, legal, and social issues of AI. So the first 3 topics are more on the technology side, but this fourth challenge is more societal side, social side. So we even have lawyers in the center and social scientists in the center, and we are discussing the ethical issues of AI or even legal issues of AI. Then finally, we are trying to grow more AI researchers and engineers. So we have students, engineers, researchers, not only in Japan, but also from other countries. And we are working together and growing together. So we are sure that computers are exact, so calculation is always correct. But if the original data is uncertain, then the outcome from the computer is also uncertain. So unfortunately, this uncertainty cannot be completely removed if the data is uncertain. But we can minimize the uncertainty. So that's actually the challenge of machine learning. So our real-world data is quite noisy and uncertain, but we want to make as accurate prediction as possible from those uncertain data. So that's the current challenge of our research. So for example, if we want to train a image classification model, we collect a lot of data from the web, and people actually label those images. Like this image contains dog, or this image contains cat, or something like that. But so once we hire a lot of people to label tens of thousands of images, then a lot of noise is contained. Then, so if we really just train a classifier only from those noisy data, it doesn't work quite well. But with certain mathematically correct algorithms, we can really suppress the influence of such noise, and we can make more accurate prediction only from noisy data. So we need to label a large number of samples. Then we need a large number of people to do that. But maybe if we hire a large number of people, then only a small portion of people are kind of reliable, and other people are maybe not really expert, but they help us in labeling data. Then those data tend to be noisy. So this is basically unavoidable. So that's why we need this kind of machine learning with under certain uncertainty. So this is really necessary to make current machine learning useful in the real world. Yeah, so that's a very good point, because the field is really changing a lot, and our topic is also updated a lot every day. So, but most of the cases, machine learning algorithms currently are quite restricted in the sense that we need certain assumptions behind. Otherwise, the method doesn't work well. Like for example, I talked about noise in data, but even if we want to cope with some noise, we need to assume that, okay, we have a certain type of noise. Then we can somehow cope with it. But if our presumption is wrong, then the algorithm actually doesn't work well. So this is actually quite problematic because often in reality, we can't really know what kind of noise we have, for example. So we really need a kind of generic method that can cope with almost any noise. So that's the first method like practitioners should use in practice. But still we are missing that kind of very generic method. And our ultimate challenge is to develop such a generic method of machine learning without really having strong assumptions behind. Yeah, so unfortunately, so machine learning contains a lot of mathematical concepts behind, but still, I think the concept of learning itself is not that complicated. We can explain that without using mathematics. For example, machine learning has 3 types of learning methods called supervised learning, unsupervised learning, and reinforcement learning. Like knowing these types of different learning methods is already quite helpful. Because sometimes people say, oh, okay, let's use AI to train this and do this job. But we need to somehow formulate that problem as a machine learning task. So to do so we need to know what kind of learning methods are actually necessary to solve that problem. So this can be done not only by machine learning people, but also practitioners or even general ordinary people in society. So in supervised learning, basically we are supervisor, human are supervisor, and we teach computers. Like that's why we need like labels of data. So we ask people to label data and train a system. So this is a quite standard way. Then unsupervised learning is, as the name stands for, there's no supervisor and computer is connected to the internet and it automatically collects data and it trains by itself automatically. But the life is not that simple, and unsupervised learning is not always performing as we expect. So we need to somehow combine supervised learning and unsupervised learning in a clever way to make it really useful. Then the last one is reinforcement learning. So this is somewhere in between supervised learning and unsupervised learning. So we don't directly teach the answer to computers, but we still evaluate the predicted answer, like how good it is. Then based on that feedback, so computers learn and behave. So its behavior is improved. So that's reinforcement learning. So all 3 are actually quite important topics, and they are all useful in many different tasks nowadays. Yeah, that's a challenging question to answer. So I was born in Japan and grew up in Japan, and I was a kind of quite domestic person until like my undergrad days. So I just studied in Japan, and I've never thought about studying abroad. But once I started like research on machine learning from my graduate school in Japan, then so I found that okay, research is really done internationally, and so there's no border. So I also need to like study abroad, have some experience outside Japan. But unfortunately, during my university days, graduate school days, I couldn't really have a chance to really study abroad for long years. But I just visited a few countries. But later on, so after finishing my PhD, I became an assistant professor in Japan, and then I had the chance to like study or kind of work in abroad for some years. So this was actually a very nice experience, and I found that so we don't have to be quick. I think I was quite slow in development from that viewpoint, but I mean it's fine. So research takes a lot of time. So even if like you didn't quite well in their early career, so it's not a problem. So keep working on the same topic for many years. Then later on, you will have even better chance. So this is what I experienced by myself personally, and hope that many students can also follow like this kind of path. Because nowadays, some people are really working quite fast and try to publish papers as soon as possible. But this is not always good in terms of like quality of research. So spending more time and going slowly is actually nicer. So this is what I believe is important. So in addition to the fact that the city is great, so the university is really good, like located in a nice place and attracted a lot of strong international students. So I personally have communication with like robotics researchers here and machine learning researchers here, and they are really working on the same topic for long years and doing something quite deep. So I think this atmosphere is really nice. And nowadays, machine learning, so applied side is quite emphasized in industry, and many people think like application is important. But in the longer run, so doing basic research is always really necessary. And University of Edinburgh School of Informatics is really doing basic research quite well, and also they have quite nice applications at the same time. So I think it's a great place to do machine learning research and robotic research. Yeah. But I still like computers a lot. So like in my childhood, I just played computer games a lot. So maybe still I want to be a like computer engineer because this really changes our life a lot.